bunch of ways to solve systems of equations. Today we're just going to deal with substitution because it's kind of related to what we did yesterday. But we're also going to use the quadratic formula when we have quadratics to deal with. Okay. A lot of these equations that are in our example problems are linear equations. That's just to learn the concept. Example 3 over there has the quadratic, which you'll have to apply in the classroom. Okay. So first off, if you like to draw, feel free to join me. First planet, Mercury, Venus, Earth. Mars has a weird orbit apparently. Okay. Why don't the planets run into each other? Gravity. Okay. Science. That's right. Science says so. They don't run into each other because the gravitational forces between the planets kind of keep them in check, right? If you really study back millions of years, it didn't always look like that. As the solar system was forming, there's theories about Jupiter actually wandering towards the sun a little bit more and then moving back out. Because you can think of all the variables of attraction of forces between the planets as it's all kind of coming into a stasis state. There wasn't as much consistency. But now you know if you're going to launch a rocket and go to Mars, you know where Mars is going to be, and you can land the rocket or start the lander. Well, it'll land like this from here on out. But you can know exactly where you want to land it because the forces of the system, of the solar system, are so consistent. Okay. So I want you to think of these systems of equations in the same kind of way, just like the Milky Way here, or sorry, the solar system. These two equations we have are within this bracket, which denotes that it's a system. So this y here in this equation is the same y as down in this other equation. It's kind of like the solar system. It's all bound by the gravitational forces and other forces. So we're able to go in between the planets, go in between this equation and this one. So with the system of equations, we can substitute variables between the two equations. We can just go in between them. All right. So here's the thing. Since y is equal to 3x, we're going to substitute 3x in place for y. So what we're going to do is take this 3x, plug it in for y. And now we have an equation that has one variable. We substitute to get rid of the variable. We remain with 1, and then we can solve it out pretty quick. So 5x and 3x, 8x. Divide 8 on both sides, x is equal to 1. Right? But the thing is, when you're solving a system, we're looking for the intersection point. We're looking for the intersection point. If I'm talking about two lines, I'm talking two lines here. If I have these two lines, if I have the system of equation, when I solve for the point, I'm really solving for the intersection point. If I have, if I have a quadratic and a line, in this case, how many solutions would I have? How many points would I need to find? 2. Okay. What would the situation look like if I had only one real solution? Who can tell me that? One real solution. How would these, what kind of graph would I need to draw? Well, let's say one is a quadratic. Okay, one is our parabola. If I have another line that is going to have one real solution with this, how would I need to set this up? What do you think? Quick. Oh, you could do that. I like that. So we could have one situation where we have the line like so, an intersection. Isaac, what do you think?
Well, I was thinking the same thing.
Oh, really? Okay, cool. I didn't think of that option. What's another option we could do? What do you think? How else can we make it intersect at one place? Yeah, Isaac, you got it?
Oh, the parabola should also be at a different place.
So you're saying we could actually move the parabola and then it would intersect at another place on it?
Yeah.
Okay. Can we move the line to have only one intersection point? We can move it or twist it, not twist it. We can move it, rotate it. What do you think? I'm asking this wrong. Okay. What I'm searching for, if we have one solution, we have one intersection point. That's one intersection point. How about if we have intersection point like that? It's going to still hit at one place, right? It hits at one place, that's one intersection point. And finally, how about if we had no intersection points? Where would the line be? Where? Invisible.
Well, I mean, like,
Existential.
I mean, like, non-existent.
So remember, solutions are where they intersect. If there's no real solutions, they don't intersect. So you're okay with me just making it up here? The purple and the blue don't intersect. No real solutions between those two. Okay. So here, instead of the solutions being on the x-axis, here, the solutions we're going to find, these points, are going to be where they intersect. So we just got to keep that in mind. Tomorrow we're going to graph these. So really I wanted to just stick with substitution, because we know so many ways to solve this, and I want you to get practice with quadratics. So let's get rid of all this and continue. All right. So we're looking for an intersection point. When you solve for one variable, plug in to find the other variable. Pretty straightforward. So we're going to use this example. We solve x is equal to 1. So we bring it over here. And my suggestion is look to see what kind of system you have and which is the easiest equation. So I point to this one. Somebody just give me a real, in your own words, why is that the easier equation to plug into?
There's only one step.
There's one step, right? Here, we'd have to multiply by 5. We'd have to move everything over. We'd have to do a little bit more. So I want you to look and see path of least resistance. I know that the easiest one is y is equal to 3x. So look what I did. I plugged my 1 for x in, and I get y is equal to 3. There's my intersection point. Okay. So just for you guys, with quadratics and using the quadratic formula. Okay, we're going to use the quadratic formula. You're going to do the same thing. You're going to substitute, but then you set to standard form. So move everything over to one side so it's equal to 0. And we'll do that when we get to example 3 here. Then you find the x values. You substitute each x value to find the y values. Your answers are in points. That's all there is to it, really. The quadratics are probably the hardest part with this, but the quadratic formula, you guys did pretty well, really well in the quiz last Friday, so I think that should be still pretty comfortable for you. I'm hoping. Okay. So let's do these example problems over here. All right. And oh, it's already focused. It's amazing. Okay. Looking at this, which should we substitute? Doesn't matter. What's our strategy? Because over here, look, we had y is equal to 3x. We put the 3x where the y is. What is y equal to for the top? 4x minus 9. Where should I put the 4x minus 9 to go to my next step? Over here, right? All right, let me rewrite that. 4x minus 9 is equal to x minus 3. You see? We haven't lost anything. I haven't just magically got rid of any terms. We just substituted it in because this is a system. Just like the solar system, we can go between the planets. We know y is equal to 4x minus 9, so I just take that, put it in place of y, and now we have the same expression on the right side. We just made them equivalent. And maybe you're starting to see, oh yeah, I can solve this out. I can solve this out. Who has a strategy for solving it out? What should I move? What do you think? Move everything? We're going to move everything to one side when we get to our quadratics. So to start, actually it's a circle. Combine like terms. So how about we move the x's to the left, the numbers to the right? Minus x plus 9. Over on the right side, those cancel. On the left side, those cancel. We get 3x is equal to 6. Finished up? Find your x. All right, again, always, since it's 3 times x, we always do the inverse operation. So opposite of multiply, divide. We do that to both sides, and we get x is 2. But what does my answer have to be in? My answer, you already found the y. Good, that's okay. So we need a point. Remember, it's an intersection of two functions. or relations, because we have a circle. But looking at this, I know x is equal to 2, so then which of these is the easiest one to plug in for x? Which is the easier one? Second one, we're going to take that down. You could choose either one. Choose either one. Y is equal to 2 minus 3. Y is equal to negative 1. There's my y. Done. Okay. So just introducing the topic. If you know how to solve with elimination, you can use that. Just again, substitution is what this particular lesson focuses on. Okay. All right, let's do number 2. 2 has a little more work to do. Somebody tell me a strategy to prepare in order to substitute. We have to prepare first. We can't just say, well, it's not like we have one variable equal to something yet. So what should I do? Put y by itself. Okay. Plus y. How about I minus the 13 over to the other side? Well, cancels on the here, cancels here. So we get y is equal to x minus 13. All right. So there's no difference between, bless you, my starting equation and this equation. I just move things around. It doesn't matter. It doesn't matter where people are seated in the car. You're still the same number of people. Bless you. Uh-oh. So now we have our equation kind of set up. What should I do with my x minus 13? Plug it in where? So make a little arrow and say, let's go in there. You agree? All right. So let's go with 4x plus 2 times x minus 13 is equal to 10. And I'm going to let you go ahead and work that all the way out for x. I'll give you all 30 seconds for this. All the way out till x. You solve for x. Question? All right, I'll just put the next line of terms down in case you are stuck. Ooh, can you see where this is going? Maybe you can already see it. Remember the design of the problem. That can also be a guide. I can see where this is going. Somebody raise your hand and tell me what you got for x. 6? Great. 6x. We add that 26 to both sides. We get 36 divided by 6. X is 6. All right, so we know that x is 6. All right, next go ahead and choose which equation up top. And you can actually use a modified equation because it's exactly the same. That is equal to this, so use either one of them. If anybody is way ahead and you want to try, plug it into the top equation, see how that works, see how many extra steps we have to do. Okay, so it looks like the easiest route for this is you take this one, let's bring it down and plug in 6 for x. 6 minus 13 is equal to y. Y is equal to negative 7. Negative 7. Done. Our answers have to be in ordered pair. Ordered pair for our answers. So this is 71. So we're going to have to make sure to put them in our ordered pair form. Okay. Let's look at example 3. So this is the example where, since we have second degree terms, we are going to go ahead and substitute, do the same thing, but we're going to solve it using the quadratic. Okay, so let's look at this. Y is equal to x minus 4. So where should I put my x minus 4? What do you think? Maya, what do you think?
I'll put it into the y.
Okay, right here?
Yes.
Okay, good. So you just have to be careful with this one. X squared plus x minus 4, which is equal to y, so I better square it, right? Y squared, so it's whatever the expression equal to y is, and you square it. Then if you look at x minus 4 times x minus 4, we have FOIL, we'd end up with x squared minus 8x plus 16. So that's if you just FOILed that out. Just did it pretty quick. X squared plus x squared minus 8x plus 16 is equal to 8. All right, everybody work really hard, combine terms, and then also set this up in standard form, everything on one side. So you get rid of everything on the other side, it's going to be equal to 0. Let's see if we can do that quick. X squared plus x squared, we have two of them. 2x squared. The minus 8x is done. I better minus the 8 to get it over. We end up with that equal to 0. Okay, so double check your work. And then this is pretty much just like what we did last week. Now we have a quadratic. We could find a, b, and c really quick. Use the quadratic formula, find your x. Plug it back in, find your y. So a is 2, b is negative 8, c is 8. Go ahead and use the quadratic and plug in all those terms. I know you all know it because you have a song to remember it, but I'll write it up anyway. All right, plug in your a, b, and c. Work it all the way out. You'll see something nice happens. If you already found your x, go ahead and plug it in, find that y, find the easiest equation to plug into. Let's see what you get there, 17. All right, let's go ahead and do this really smoothly. Squared minus 4 times 2 times 8, all over 4. So we end up with, first off, what's our discriminant in this case? What's our discriminant? What's in the house? How much?
0.
0. So if it's 0, how many solutions do we have?
1.
Only one. Okay, only one. So I know that I end up with 8. All this right here was 0 over 4, so we get, really it's 8 over 4. It's x is equal to 2. All So if we're looking for our point, we know that x is 2. And how about finding the y? Which one should we plug into? Thank you. Let's take this, put it down. So y then is equal to 2 minus 4. Y? -2. And I had to double check, but this is basically a circle. X squared plus y squared is equal to 8. The radius is equal to the square root of 8. And we'll go over this more tomorrow. I just want to give you a peek. So this line here, y-intercept -4. Your slope is 1, 1, so we go up this way. So this is a really basic drawing, but you can see that the one intersection point is just where those two touch, right? So I actually didn't know what we were going to get down here. I just drew it, and that's what we're going to do tomorrow. You're going to use Desmos, and we'll work out the graph, and then you can see the intersection point. That's our solution. Okay? So let's see. You have about 6 problems, like example 1 and 2, and about 4 problems for example 3. Maybe 3 problems because it's a little extensive. So from there, are there any questions? How about this? Thumbs up, sideways, or down for this? Working forward, feel pretty confident? All right, that looks pretty good. All right, let's see. Just want to remind the viewers. Kind of want to change the Oreos. Maybe no. Oreos are good, and they're vegan for the vegans. All right, 123rd gets a free Oreo package. What's that?
Yeah.
Package.
Little package, like
I was thinking like a package that's about this big.
That's actually some pretty good dimensions you got there.
Yeah, that's right. I mean, it's a full package of Oreos.
Yeah.
All right, don't forget to subscribe. Don't unsubscribe and subscribe.